Welcome to Subaru Ecu Flash Training Part 17. In this video, we're going to be taking a look at our miscellaneous fuel tuning that we're going to be finding within a carberry-based ROM. This is going to be things like our O2 smoothing factor, or the forced open loop factor, or going in and being able to recalibrate our air fuel to milliamp table in case we relocated our oxygen sensor from the stock exhaust manifold into the downpipe. There's a lot of little tips and tricks we're going to cover in this training tutorial, going over again these miscellaneous details that we haven't covered yet in our previous training videos in our training course. Without further wait, let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at some miscellaneous details with our fuel delivery that I want to cover before we move on to doing other topics such as spark timing or boost control, because these can make a difference in some things that you need to know and keep in mind if you're running into some odd fuel delivery problems. This is going to help you sort some of those details out. So what we want to first talk about and take a look at is going to be something called O2 smoothing. Now, this is going to be specific to the carberry ROM. It's not available in a stock Subaru-based ROM. O2 smoothing is going to allow us to smooth out how the oxygen sensor is processed by the ECU. You may notice as you're going in and you're logging in ROM Rader here, we have our air fuel correction number 1, that's our short-term adjustment. We also have our air fuel learning number 1, that's our long-term fuel trim adjustment. Then we have our different air fuel learning stored values, A, B, C, and D. We've talked about these extensively. You may notice that your air fuel correction here is relatively erratic. It might be all over the place. You might find it's going from 10 to -8, back to 10 to 5 to 2. You might find that this is moving around a lot within a very short period of time. Now that's not good because as it moves around, it's constantly adjusting the injector pulse width, as we've talked about. It's trying to match your air fuel to what the closed loop fueling target's going to be at idle and part throttle situations. Some vehicles suffer from having the oxygen sensor get essentially bad data back to the ECU, and that can cause drivability problems, and that can cause fuel delivery problems. We'll find that taking a look at the pulse width, it's going to be following what your corrections are going to be doing here in closed loop, and that may not be ideal. Again, it can create drivability problems. So if we're having bad O2 data, if it's unsmooth for whatever reason, that can create these injector pulse width discrepancies and ultimately air fuel discrepancies, which can be felt during driving. So if you find that your air fuel correction is pretty erratic, it's all over the place, you're going to want to probably implement the O2 smoothing. So let's go take a look at how to go and work with this in the carberry ROM. If we jump back into our ROM, this is a speed density carberry ROM. We've been using this in the last few training tutorials. And we go under current ROM metadata and we scroll down here towards the bottom under O2 smoothing. This is where we can actually turn this on at. Now the O2 smoothing based on map pressure. We'll find that the map pressure is relatively consistent and linear within the Subaru operation if it's mounted on the throttle body in the stock location. Now we can smooth out the oxygen sensor signal as to how it's processed by the ECU based on the map pressure sensor because it is relatively linear. We wouldn't want to do it necessarily on the MAF sensor, the mass airflow sensor, because that can get erratic readings depending on where we place the MAF sensor. So it's important that this is based on map pressure. So if we go here and we can click on disable and we use our right bracket key, this is going to be turning this to enable. By enabling this, it starts to enable all of our subtables here. They're going to be modifiers to smooth out the oxygen sensor's reading. So if we go here into O2 smoothing map thresholds, this is going to be defining the mid and high smoothings. So the mid is going to be under 14.21, and then the high smoothing is going to be over 14.79. Now in this situation, this will smooth out essentially closed loop versus open loop. So the mid is going to be applied for closed loop, the highest smoothing is going to be applied for open loop. Now taking a look down here, we're going to have our different mid-low conditions. This is going to be a percentage current, AFR additive, high, mid, low. We're going to see this is the percentage of smoothing factor here and the additive that's going to be smoothing it out. So it's going to be essentially taking our corrections that we're finding here and refining it and smoothing them so they're not as erratic, which ultimately should deliver to better injector pulse width delivery and ultimately better air fuel delivery, more consistency. This can improve drivability, so you might want to test with this on and with this off. Up to this point in the training tutorials, I haven't turned it on. I've done all of the calibration and tuning with it off and all the data capturing and sampling, so that might be something again to experiment with. Tune everything.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.